All right, so a volume of a pyramid, this comes from the idea of the volume of a prism. And it's how many pyramids can actually a prism be cut into. And I'm going to try and get a visual. I tried looking for a visual this morning, but it didn't really look nice. So I'll try and find a visual tomorrow so that we can see this. But what we know is that we can really create out of prisms, we can create a 3 pyramids. So our volume is going to be V equals 1/3. And then of that prism amount. And that prism amount, remember, was area of the base times height. Okay, so capital B, remember, is area of the base, not just the base, area of base. And H stands for the height of the pyramid. Now, this time we are going to be looking for the whole height of the pyramid, which means we're going to be looking for that 90-degree angle. When we did surface area, we didn't use height. Does anyone remember what type of height did we use for surface area?
So the kind of clue in that question is, so what type of height do we use for surface area?
It's surface area.
Surface area is looking at that outside, so we use that slant.
But because this time we're looking at volume, and volume is the inside amount, we'll actually be looking at the total height of that pyramid. Okay, I'm going to use orange for base today and yellow for height, because that is what I've been doing for almost all of these lessons.
One little blue in here, and then 2 examples.
Go ahead and glue that in. You don't need to cut it today unless you want to be a perfectionist and trim different parts. Otherwise, we just have that one formula that we're following today as we work. Alright, so when we look at this with this capital B, remember that stands for area of base. And so what I'm still seeing is a couple of us struggling to say, okay, well our base looks like it's just 5, and that's it. That would be like little b, that would be the lowercase base. We want the uppercase base, so we need to be using area formulas to find that area of the base. So when we look at that, we're going to look at and see what type of base we have, what is our shape. So in this first one, what is the shape of our base? Triangle. So this one is a triangular pyramid. So when I find my area of the base, I need to think, how do I find the area of a triangle? What is my formula for a triangle?
A lot of you have that kind of memorized now already. If you wanted to look back for area of a triangle, you could, but can anyone remember how do we find the area of a triangle? 1/2 base times height.
Good. So as I look at this base, I'm looking at just this bottom triangle here. You know, you can use highlighters, or if you want to use colored pencil, you could do that. Okay, so for my base, I'm going to be doing my 1/2 times, now my base and height of a triangle have to make 90 degrees. So as I look at that orange triangle, I'm looking for where is there 90 degrees that's laying on that orange triangle. Not going through it, but laying on it. Where do we see that 90-degree angle? And this one's a right triangle. So with a right triangle, we're going to be using the two sides that come together. So where do we see two sides coming together to create 90 degrees? Good, 3 and 4. This one we might be able to do in our head. What's 3 times 4? 12, and then half of 12? 6. Could also use a calculator. Okay, and then we have our height of our pyramid. So now this time we're looking to see how tall does this go. What is our height? And we're going to look for a 90-degree angle, but this time we want it to go to the vertex, where the point is on that pyramid. So my vertex is up here, and I want that line going down through the pyramid that creates that 90-degree angle. So our height is 6. Whoa, our base and our height are the same. Crazy. So then we're ready just to plug it into our formula. V equals, and our formula was 1/3 area of our base times our height. And what is the area of our base? Six, and our height? 6. I know. So 1/3 of 6 times 6. A third is like dividing by 3, so you could think 6 divided by 3 is 2, and then 2 times 6 is 12, or we can plug it into our handy-dandy calculator here. 1/3 times 6 times 6, and we get 12. And how am I going to label this volume? Cubic units, and what are we measuring in? Yards, cubic yards. Nice job, Valerie. Cubic yards, so yards with that 3 exponent, but we say cubic. All right, we just have one more example here. Mine is going to be a little bit lower because that was all for that one. All right, when we look at this next pyramid, we see it's a pyramid because it comes to a point. Does anyone remember what we call this point that a pyramid meets at?
All the sides meet.
Vertex, good. So since we have a vertex here, we know that this is a pyramid. To find the base of the pyramid, we're going to look opposite of the vertex. So vertex is on top here. What's opposite of that vertex? What kind of shape are we working with? Yeah, a hexagon.
How many sides does a hexagon have?
6. Oops. How'd this get so crooked? There we go. So as we look at our base, we're looking at this hexagon with 1, 2, 3, 4, 5, 6 sides. So we need to know, how do I find the area of a hexagon? And that's for my capital B, my area of my base. What's our formula for a hexagon? One half not quite. Base 1 and base 2 would be with a trapezoid. This one's that regular polygon where we use the apothem and
What, Henry?
perimeter. Good. Apothem, perimeter. Whoa. Alright, so we're going to have 1/2 times what's our apothem in this hexagon. Holy moly. 5.2, thank you. Alright, and then I need the perimeter. So for my perimeter, I'm looking for all the outsides together. So what's one of the sides? 6. And I need to know all together, and how many sides did we say there were? 6. So we can think 6 times 6 to find that perimeter. And 6 times 6 is 36, right? So now we're going to find that. I need a calculator for this one. 1/2 times 5.2 times 36. And we get 93.6. Okay, and that was the area of our base. Now we also need to find our height. And this is the height of the pyramid. So for a height of the pyramid, we want to start at the base and go to the vertex. Go to that peak of the pyramid. So as I start at the base and go up towards that vertex, I'm looking at kind of this middle one. This one is not part of the outsides. It's just going through the middle of the pyramid. And our height is 12. So our final step there would be to actually plug it into our formula for volume. Volume equals, remember it's 1/3 area of base times height. So 1/3 times, what's the area of our base? 93.6 times, what's our height? 12. And again, I would plug that into my calculator personally. 1/3 times 93.6 times 12. And we get 374.4. And again, we need our label, cubic kilometers. Not squared. Remember, we're doing cubes. We're seeing how many cubes fit inside. So we want that to the 3rd power. So cubic kilometers.